Let's look at this problem. Factor 3x squared minus 11x plus 6. And what makes this one different than all the others we've done up to this point is that the leading coefficient is not 1. In this case, it's 3. And also this coefficient, or this constant term, is not 1 also. So it turns out that there are more possibilities, more possible pairs of numbers that we have to work with in order to find the right set of numbers that factors this correctly. And now the technique I've been showing you for factoring trinomials, I call it an educated guess method. I don't know if there really is a term for it, but that's my term, educated guess method. And so we'll continue on with that. And this is how most people factor that have a lot of experience in factoring. They do things pretty much similar to what I'm showing you. All right, well, first of all, is there a greatest common factor we can take out? No, because 3, 11, and 6, well, 11 is a prime number, and we can't factor, say, a 3 out, for example. Can't factor an x out either, so that leaves us, our only remaining possibility is can we break it up into a product of binomials? Now, I always like to do the easy stuff first here, and that would be the variables. So x's have to go here. Now we need a pair of numbers here multiplied together to get 3. And there's only one pair, it's 1 times 3. And then we need a pair of numbers to go here to multiply together to get 6. So now we're looking at, in these kinds of factorings, where the leading coefficient is not 1, we're going to have to consider 2 sets of factors, and which is going to provide more possibilities to work through. All right, now this is an easy one because the only way to get 3x squared is to have 1x times 3x. So I'm going to take care of that first by putting a 3 here. So I have 1x times 3x is 3x squared. That's taken care of. And so that factor, of course, is used. Here, is it 1 times 6 or is it 2 times 3? And where would we put these numbers? Okay, exactly. When we factored the trinomials in the last video with leading coefficient of 1, then finding the right pair amounted to finding a pair that added or subtracted to give us the middle number. That doesn't work on this type of trinomial. That no longer works, so we just have to do a little bit more trial and error. Now, I find normally that when I factor it in this kind of order, where I have 1 times the number, and then I work my way down the list, I find more often than not that the pair on the bottom of the list is the most likely one to fit in here. So I'm going to start looking at 2 and 3 and see if that pair will fit and factor this correctly. All right, now where would you put 2 and where would you put 3? So I'm going to, I'm actually going to do it wrong first. All right, but I want you to see why this is wrong if I put a 2 here and a 3 there. So what could be wrong about that? Well, we do get 3x squared, we do get 6, and do we get 11? No, we don't. You know, the outer terms would be 3x, the inner terms product would be 6x, so 3 and 6 cannot give us 11 by addition or subtraction. But there's another reason why you don't even have to go that far. You know, why is it impossible to put a 2 here and a 3 here? And what I want to point out is that if we put this factor of 3 in with the 3x, then if you look at this binomial, 3 will factor out. 3 does not factor out of the original trinomial. So we can never, it would be impossible to break it up so that 3 would be a factor. And so that alone disqualifies 2 here and 3 there. And so, you know, it's one of those little things that if you know it, it's a time saver. It's a time saver. So I'm going to switch those around. Let's put 3 here and 2 there and see if that works. And so I get 2x and 9x. I can get 11 out of 2 and 9. So Now we need to fill in the signs. To get a plus, I need the same sign. So these are either both pluses or both minuses. And with the middle term being minus, these have to be minuses. So let's check this factoring. I got 3x squared, that's correct, minus 2x minus 9x, that's negative 11x, and then positive 6. So it's factored correctly. All right, well, let's do another one.